Hey, physics. Oh man, my foot is asleep. That sucks. All right, we'll deal with that later. Um, y'all just did the lab on making this circuit, which is the circuit with a 15 volt battery, two 15 ohm resistors, a 30 ohm resistor, and a 60 ohm resistor, and then there was the series version, which I'll make momentarily. But you should notice that the charges are flowing fastest here, and then you have different amounts of current flowing in each part. If I wanted to actually measure that current, what I could do is place an ammeter in there and it would measure out. So that is the current for that segment. Here is the current for that segment. Right, and I can just continue to repeat this. Right. It should be expected that the two 15 ohm resistors have the same current going through them. The 30 ohm resistor has less, and the 60 ohm resistor has even less. If I want to measure the total current going through everything, I could just measure what goes through the battery. Y'all probably saw that if you add together 1 plus half plus 0.25, you get 2.75. All of the individual current branches should add up to what goes through the whole thing. That should kind of make sense. The charges might split up to go through the different pieces, but they will all come back together at the end. The other thing that you guys should have seen was that the voltage before and after for each of these was 15 volts, right? Because we have 15 volts in the battery, so they should use all of that voltage to get through this resistor and then come back through. Now here's the thing, right? I'll use this example where it's the 30 ohm resistor and the 15 volt, what's it called? Battery. Got a new thing here. We'll see how well or how not well it works. Ooh, okay, it's kind of working again. If I were to draw the kind of like simplified version, right? Then I have a resistor and a resistor and a resistor and a resistor, right? So this, say this one was 15 ohms and 15 ohms and 30 ohms and 60 ohms, and I know that this is 15 volts. Right, well I know, so here's an equation from your reference table, which is V equals I times R. And if I know that, let's say this is R3, so the voltage through R3, so voltage 3 is 15 volts because it uses all 15 volts to get through, and then the resistance at 3 is 30 ohms. So what is the current here? Well, I can use the equation. I could say that 15 volts equals I times 30 ohms, which means that 15 over 30 amps should equal I, which is 0.5 amps, which is exactly what we read on the ammeter. And that should make sense, all right? What I want to point out is that you can use Ohm's law, which is that equation right there, V equals IR, for individual pieces of a circuit, or you can do it for the whole circuit. And what I mean by that is, if we look back over here, we said the current whole thing was 2.75 amps, and the voltage for the whole thing is 15 ohms. So let's do this. Let's use Ohm's law, but let's do it for the whole thing. So the voltage, the total voltage is 15 volts. The total current was 2.75 amps. What is the equivalent, or what is the total resistance? Right, so again, we'll do V equals IR. 15 volts is 2.75 amps times the resistance. So the resistance is 15 divided by 2.75. which I'm not going to do off the top of my head because I have gotten that wrong enough times. 15 divided by 2.75 is 5.45 ohms. Right? So it should be 5.45 ohms. That's the total resistance, right? Well, if I wanted to do total resistance for parallel, then I would have to do 1 over 15 plus 1 over 15 plus 1 over 30 plus 1 over 60. That's going to be 1 over the equivalent, right? Because that's what it says in the reference table for a, what's it called? For a parallel circuit. And I know you can't see the 60, but it's right there. I just drew 60. So let's common denominator this, everything over 60. So that's 4 over 60 plus 4 over 60 plus 2 over 60 plus 1 over 60. Well, that is 4 and 4 is 8, plus 2 is 10, plus 1 is 11. That's 11 over 60. But that equals 1 over the resistance. So I need to flip that. So the resistance actually equals 60 over 11. Y'all want to guess what that's going to be? I'll do the math. Open the calculator. 60 divided by 11 is 5.45. 5.45 ohms, which is exactly what we got the other way. All right. So you may be posed with a question, probably not as complicated as this. Probably won't have 4 resistors. We'll probably only have 2, maybe 3, probably 2. Where you might be asked about the voltage in a certain spot or the resistance in a certain spot. And my hope with the lab was that you saw, oh, the voltage in parallel is the same everywhere, so it wouldn't matter where I read it. The current is going to depend on where you are, but if you know the voltage and the resistance, you can know the current. All right? The other thing that hopefully you saw when you put this together as... Okay, let's start getting rid of pieces here. Actually, let's just reset the whole thing and probably be faster. So if we have this connected to this, let's make this guy 15. Let's make this 15. Let's add another resistor, which is 15. Let's add another resistor. This one was 30. Let's add another resistor. This one was 60. Let's add an ammeter because I want to read the current, and then let's grab a wire. Boom. Alright, now, this has to go through everything. There's only one pathway. This is the simplest version. This is bare bones pieces, but they're moving. They're moving very slow. The current through this is only 0.12 amps. Right, so if I do this, I have the battery connected to a resistor, connected to a resistor, connected to a resistor, connected to a resistor, and then just all the way back through. So 15, 15, 30, 60. This was 15 volts. I'm looking for the total current. In order to do that, I need to do the equivalent resistance, which is 15 plus 15 plus 30 plus 60, which is 15 is 30, and 30 is 60, and 60 is 120. There's 120 ohms of resistance in this 15 volt circuit. Voltage equals current times resistance. 15 volts is current times 120 ohms. If I do that math, I end up with 0.12 amps as my current. And that's what we saw. Now what we can do here is I can use this, because there's only one pathway, there's only ever one current. Wouldn't matter where I measure it, only ever one. I can use that current to figure out how much voltage is used here, or here, or here, or here, right? So this current is what I can use, and I can use V equals IR. I can use Ohm's law again. If I want, let's say I want to find what is the voltage through the 30 ohm resistor. I'll use resistor 3 again. So we'll call this again R1, R2, R3, and R4. Right? So let's say that I want to know what is V3. Right? Well, I know that the current is 0.12 amps. I know the resistance is 30 ohms. So V equals IR. Scroll down a smidge. V equals IR. So that means it equals 0.12 amps times 30 ohms, which is, and again, 0.12 times 30. It's 3.6. So it should be 3.6 volts. Well, if I take a voltmeter, there we go. If I take a voltmeter and I measure from one side of the 30 to the other side of the 30, 3.75, we got 3.6. What did I do wrong? Nothing. Might have been, no. Why did I get, oh, is it, wait a minute. It's 0.12, 0.12 is rounded. Hang on. Something hinky. 20. That's 15 divided by 120. Yeah, 0.1, okay, so it should be 0.125. So limitations. There are limitations to the simulation. If I use 0.125 amps, this is 0.125, that is how I would end up with 3.75. There's my extra 0.15. 3.75 volts. So we use 3.75 volts to get through that. I could do it for V4. I would just replace 30 ohms with 60 ohms. I would end up with half of that. No, double that. 7.5. It'd be half. 7.5. And if I actually measure from one side of the 60 to the other side of the 60, I get 7.5, right? Now, that is a minor limitation of the simulation, is that it will only go out to 2 sig figs. So if you have more exact measurements to take, you will have to use that. But again, I can use Ohm's law. I can use V equals IR to solve for something involving the whole circuit. Or I can use V equals IR for something that only involves a part of the circuit. If you are looking for a small part, use a small part. If you are looking for the whole thing, use the numbers for the whole thing. All right. There are a couple of short answer examples that I want you to look at. I think we're back to June 2015 and one from June 2016, but there's almost always a short answer question that involves interpreting a circuit entirely. I've cherry-picked a couple of them, things that I knew you could do already, but now, knowing this, having done the lab, I want you to try to answer those questions, all right? This is the last thing, and then I'll take, any random questions, some last-minute stuff to look at before the test. Test will be next Monday and Tuesday. In class, for people who are in class, I'll email it out at a certain time for fully remote students, and I want it back like an hour later, 40 minutes later. You'll be timed. But yeah. All right, that's trying out a new thing. Obviously, I'm playing with it, but the labs looked pretty good. The only weird things were forgetting what the ammeter does, or not correctly identifying what the relationship is for the the voltage in a series circuit. I think that was the one that was most frequently missed. Overall, they were good. Like no real complaints. You guys pretty much nailed that right on the head. So, well done there. All right. If you have questions, email me, obviously. Otherwise, I will see you next class or next video. Take care, kids.